surface weather provides the best flying conditions. Avoid situations where cloud shadows may affect lighting conditions. If the flight path altitude is to exceed 120 meters, an airspace clearance must be applied for in advance. First, prepare the Jean de Rouge Airborne hyperspectral camera and fit the lens. Place the drone on a flat surface, extend the arms and lock them into place. Then mount the spectral camera gimbal assembly onto the drone's lower mounting point, aligning the white dot on the gimbal with the red mark on the drone's mounting point. Rotate the gimbal 90 to the right until the red mark on the gimbal is perfectly aligned with the red mark at the front of the mounting point. First, plan the route and create it in the route database. Select a route by area. Mark out the target area for the flight. Select custom camera in the workload and create a new camera. Setting the camera parameters. Next, configure the flight path and set the required altitude, keeping altitude optimization disabled. Set the cruising speed according to the instructions on the remote control. Open the advanced settings and set the lateral overlap to 65% and the heading overlap to 80%. Leave the rest as default. Once finished configuring the settings, click Save. First, calibrate the spectral camera and position the target within the flight path. Then lift the drone about 40 to 50 centimeters off the ground and, whilst filming the target, adjust the settings as follows. In the load settings, enable the display of real-time data and set the exposure time to the system's maximum value of 19,403 microseconds. If there is sufficient light, reduce this slightly to avoid overexposure. Referring to the feedback values from the target, manually adjust the gain so that the light intensity remains stable between 10,000 and 20,000. That is, the peak of the hyperspectral curve should fall between 10,000 and 20,000. Leave the other settings at their default values. The second step is to capture a dark field image. Completely cover the lens with an opaque object. Click the Enable Dark Field button in the load settings and allow the system to record the dark current noise. After approximately 5 seconds, click the button again to allow light to enter the lens as normal. Tap Start in the top left corner to create a new flight path. After completing the pre-flight check, upload the flight path. Then tap Start to begin the flight, and the drone will fly to the starting point. Once you reach the starting point, tap the Capture button, and the drone will begin capturing footage. Once the flight path has been completed and the drone is hovering, manually switch off data collection. Once the flight is complete, press and hold the latch at the connection point and turn the gimbal to the left to remove the spectral camera. Once the flight is complete, insert the USB stick into the rear port of the spectral camera to export the data. Select which flight's data you wish to export. Import the visible light imagery acquired during this flight into the image stitching software, and stitch the visible light and DSM images together. Select New Project, and import the source image. Click Next to begin stitching. Once the mosaic is complete, click on Orthophoto and DSM to export the visible light and DSM images respectively. Open the Wayho Spectral Remote Sensing Industry Application software and stitch together the spectral data. Import the data. First, locate the target in the image. Click on Radiation Correction. Select the target with the selection tool, and note that the target's albedo is 0.3. Then click Route Trimming and import the GPS file. Begin cropping. Remove the images taken during turns at either end of the flight path, retaining only the valid strip data collected whilst flying level. Once cropping is complete, import the previously stitched visible light and DSM images as a georeferencing baseline, and automatically align the spectral imagery with them. Once alignment is complete, a mosaic of reflectance spectra with georeferenced coordinates is obtained, and the basic data processing is completed.